Ever wonder what happens when someone finds a single tiny part on an airplane that just isn't right? It's one of those things you hope you never have to think about. But when it does happen, it kicks off this incredible global process designed purely to keep us all safe. So let's dive into this. We're going to look at a hidden flaw and the amazing system that swings into action to fix it. So, this is the big question we're tackling today. Imagine a manufacturer realizes a batch of parts was made with the wrong material. And those parts, they're already on planes flying all over the world. What do? What happens next? Well, it's a huge puzzle, really, involving engineers, regulators, and airlines, all in a race against risk. All right, so our story begins in a really critical but maybe overlooked part of the plane, the tail fin. This is where a tiny little deviation from the design blueprints set a massive safety process into motion. Okay, so let's talk about the vertical stabilizer. You and I, we just know it as the big fin on the back of the plane, right? Well, its job is absolutely essential. It keeps the aircraft flying straight and stable, kind of like the feathers on an arrow. Without it, you're not getting a smooth flight, that's for sure. And here we go. This is the core of the problem. The manufacturer, a company called ATR, figured out that inside that super important tail fin, some small but vital junction parts, we're talking the ribs and lugs connecting the fin to the rudder, were made from a material that didn't meet the specs. Simply put, it wasn't the right stuff. And that, well, that could have some serious consequences down the line. So how in the world did anybody even find this? Now, this is the cool part. This discovery didn't come from an accident report or some incident. No, this is a story about a system that's designed to find problems before they become catastrophes. Get this, it was the manufacturer, ATR, that found the problem themselves during their own quality checks and analysis. They were able to pinpoint the exact models affected and identified the big risk here, that this incorrect material could weaken the tail's structure over time, and that could potentially lead to failure. I mean, this is the definition of proactive safety, finding a problem and raising the alarm yourself. So once a manufacturer reports a problem like this, the regulators have to step in. In this case, it was the European Union Aviation Safety Agency, or EASA, and they issued what's called a Proposed Airworthiness Directive. The easiest way to think about it, it's like an urgent, mandatory recall notice for an entire fleet of airplanes. Now, the response here isn't one size fits all, which is pretty smart. EASA split the affected aircraft into two different groups based on risk. Group 1, those are the higher risk planes, they need a super thorough one-time inspection done within about 2 years. Group 2, the lower risk bunch, they get a less intense but repetitive visual checkup every 24 months just to keep an eye on things. So if you're an airline, what does this actually mean for you day to day? Well, it boils down to this really clear 4-step process. First, you've got to check your fleet and figure out which of your planes are on the list. Then, you schedule and perform the specific inspections they've mandated. Step 3, and this is critical, you have to report everything you find back to ATR. And finally, if you find any damage, any at all, that plane is grounded. It doesn't fly again until a repair is approved and completed, period. Now, a directive like this, it doesn't just happen in a vacuum. It creates this huge ripple effect for the airlines that have to deal with it. It impacts pretty much everything, from their flight schedules all the way to their bottom line. You can kind of break down the impact into 3 big buckets. First, and way out in front, is safety. That's the critical, non-negotiable priority. Everything else comes second. Then you've got the operational impact. I mean, you have to take planes out of service for these inspections, and that messes with schedules. And finally, yeah, there's a financial cost. You're paying for labor, parts, and all that downtime. But look, inspections are really just a temporary fix, a way to manage the risk. The ultimate solution is replacement. The directive sets this hard limit. Before any of these planes hits 36,000 flight cycles, and a flight cycle is 1 takeoff and 1 landing, those non-conforming parts have to be replaced, no matter what the inspections say. This makes sure the problem is solved permanently. So why did we just walk through all these technical details? Because this whole chain of events is just a fantastic window into the invisible, systematic process that ensures flying remains one of the safest things you can do. And you can see it's not some chaotic scramble. This timeline shows just how structured it all is. First, the directive is proposed. Then there's a consultation period where people can give feedback. Only after that does it get finalized, and then the clock starts ticking for the airlines. It's all very deliberate, transparent, and methodical.
And if you want to know the why, it's laid out right here in this quote from the official directive. The whole point is to address an unsafe condition. The language is super direct and clear. It's not about pointing fingers, it's about finding a potential risk and just neutralizing it, getting it out of the system before it can ever cause harm.
When you boil it all down, this whole story is really about collaboration. You've got a regulator like EASA working hand in hand with a manufacturer like ATR. They're sharing information openly, working together for one single goal, making sure every single aircraft in the sky is safe. It's a system built on trust and transparency, and it works. So the next time you board a flight, you can feel pretty confident knowing there's this entire global ecosystem of checks and balances, just like this one, working behind the scenes. And it kind of makes you wonder, right? What other invisible systems, what other hidden processes just like this are quietly working every single day to keep our really complex world running smoothly?